So the next topic is how to give code to a thread to get the thread to run. And this turns out to be kind of an interesting topic with a bunch of different variants, different ways of doing things. It turns out that there are two general ways of doing it, and one of the ways has several alternatives. So we're going to talk about those different ways. First and foremost, if you want your threads to do anything, you have to give them some code to run. It doesn't do any good to just create a thread that does nothing and give it no code. It'll just, even if you start it, it'll just sit there and consume resources without actually having any effects that are meaningful. There's, oddly enough, a no argument constructor for thread. There's a version of the thread class constructor that takes no parameters. But that makes no sense whatsoever because it doesn't have anything it can do. There's a Stack Overflow discussion of why would you ever even use this thing? The answer is you don't want to use it. There are several different ways of giving code to threads, and that's what we're going to talk about here. The first way, which is arguably the simplest way to do things, and sometimes it's good, sometimes it's bad, is to simply extend the thread class itself. So if you take a look at this code here, you can see that we have a class called GCD thread, which is the implementation we're working on here. And that extends thread, and then it goes ahead and it fills in the run hook method with the code you want to have executed in a separate thread of control. Very straightforward way to do things. The way you would do this, or one way you could do this, is you could say new GCD thread, make a new instance. In this case, we're going to store it in a variable called GCD thread with a lowercase g, and then we're going to say GCD thread.start. And that will go ahead and create the resources necessary to run the thread, most notably create that runtime stack, and then arrange to call the run hook method in that runtime stack. And we'll talk a bit more in just a moment about how threads actually run when you start them. But for now, just imagine that in this case, we're explicitly naming this thread and we're giving it something to do. You could also anonymously create a thread. You can just say new GCD thread.start. That will also create a thread to run the GCD computation, but it won't store the thread reference in a variable. And the main reason you might want to do this as opposed to that is once you have yourself a thread reference, you can do other things to it, like cancel it, or you can join it, and so on. Not necessarily right or wrong to do it this way. It's just an alternative way to do things. It's called an anonymous thread. The second way to give code to a thread is by implementing the Runnable Interface. And again, we'll see later when we talk about this, there's some pros and cons to doing this. So in this particular case, what you do is you implement using the implements keyword, or some other means we'll talk about in a second, the Runnable Interface, and then override the run hook method. So it's very similar to extending thread and overriding run. It's just that we're implementing runnable. And I'll talk later about why you have different approaches. There are a couple different ways to do this, to implement the Runnable Interface. One way to do this is to create a class. So here we have class GCD Runnable implements Runnable with the run hook method. And then we could say new GCD Runnable. So that's one way to do it. That's a sort of an explicit or overt way of creating a runnable. And then once you have the runnable, then you can say new thread and pass that runnable as the parameter to the one argument constructor. And that will then go ahead and associate that runnable with the thread such that when you call start and the stack is created, that run method in that runnable will be what will be called in the new thread of control. So that's another way to do things. Here's another way to do things. This is what's called an anonymous inner class approach, and this is very popular in older versions of Java. So what you do here is you make a new thread, and you make a new runnable, except that this runnable, rather than making a separate class, as we had done over here, we're now going to create an anonymous inner class, as it's called, where we're going to define the run hook method there. And this is all kind of self-contained. So this particular runnable object is not part of some separate class. It's just an anonymous inner class. This is used a lot in older versions of Java and older versions of Android. With modern versions of Java, and by extension modern versions of Android, you don't have to do this anonymous inner class approach, which is honestly a little bit tedious and error-prone to write. And instead, another way to do this variant is to use a lambda expression or a method reference. and you'll get a chance to play around with that in your programming assignment. So what you do here is you give a lambda expression where you say open, close, because it's an expression that takes no parameters, so it's a runnable, basically. Then you have the arrow. This is just sort of syntactic sugar. And then the code that you want to write goes there. So rather than writing this monstrous, ugly, carpal tunnel syndrome-inducing, tedious inner class code, instead you can run this much more concise code, which just has the computation to run. This approach is nice that this is sort of a one-liner, but if you end up with a lot of code in there, you're probably actually better off storing that into a runnable like this. You can actually store a lambda expression into a runnable variable and then pass that variable to the thread in its one parameter thread constructor. So this is one way to do it. That's kind of the anonymous lambda. And then you can also have a named runnable and then pass that in. It has essentially the same effect. This would make sense if this is a lot of code and or if you're going to reuse that runnable multiple places and you don't want to write that code over and over again. So those were the primary ways of being able to give code to a thread to run it. For the purposes of this class, I would recommend that you learn to use the lambda expression approach here. It's not required, but it'll just make life so much more simple, and it's pretty straightforward and easy. It's arguably much easier than writing code like this, and less work than writing code like that. So I think that's probably what I would recommend. But if you have any questions about that, please don't hesitate to ask, and I can point you to some good videos that will teach you about lambda expressions.